Hi everyone, my name is Ayobami Tawagbade. I am a DevOps engineer with Reliance Infosystems, and this is to welcome you to Introduction to Networking course. So I'll be your facilitator for this course. Now this course is divided into about 9 modules that covers the basics of networking from the building of a small network to IP addressing and subnetting, basics of building a home network, and basic network security concepts. So let's get started with Module 1, which covers communicating in a connected world, local networks, and how to build a simple network. Now, as we all know, networking is basically the connection of one or two or more devices for the purpose of sharing information. Now, the largest form of network that we already know is the internet, which enables communications of all forms from voice to video to reading of news to even working remotely as we have in the modern world. Now, every one of us is obviously online, and that is why we are able to do this that we are doing. Now, who is the owner of the internet? The internet basically does not have an owner, it's just a worldwide interconnection of networks that has been designed to exchange information using common standards, which ensures that the communications are happen seamlessly regardless of your location and the type of devices that you are using to communicate. Now we have various types of networks by virtue of the sizes. The smallest kind of network is the peer-to-peer network, which can be as simple as the connection between your mobile device and your smartphone. Sorry, your mobile device and your smartwatch, or your mobile device and your probably your Bluetooth headset and stuffs like that. That is a peer-to-peer network. It's just about the simplest kind of network. Now it can grow a little bit more to include you connecting your mobile devices to your smart TV, to your home router, your laptops, and other gadgets that you have in the home. This can also grow to what small businesses use that includes network printers, scanners, fax machines, and a host of other devices that are used in an office setup. Then we also have networks for larger organizations, telecommunication, the banks, and a host of others. Now, making connections happen. For connection to happen, there are various types of devices that needs to be present in the architecture. All this we'll discuss in the upcoming slides. Now, the next section, the next slide is talking about what is the essence of communication. And obviously, the essence of communication on a network is to transfer, to exchange data. Data is can be described as whatever is of value to an individual or a business. And we have various types of data. We have the volunteer data, such as what you offer voluntarily on the internet, on social media platforms. We have observed data. Those are data that are collected by your devices, like your location, your temperature, the humidity. All these are collected by sensors. Then we have the inferred data, and inferred data is an example of that is when you have your biodata with your bank, for example. With your date of birth, they could easily infer your age, and with your age, some restrictions and policies applies to what you are able to do and all stuffs like that. So those are basically the three categories of data that we have. Now, how do you transmit data on a network? Data are transmitted using what we call the network media. Now, this network media can transmit bits. Bits is, of course, the smallest unit of what you can transmit over the media. Now, getting these bits to be transmitted can be through pulses of electricity like we have in a copper cable. It can be through pulses of light, like we have in optic fiber cables, and this can also be through pulse radio waves, like we have in satellite communications and cellular networks. Then, while communicating, there are also units of measuring the rate of communication. We have what we call the bandwidth, which is the amount of data that can flow from one place to another. Then at the same time, we have what is called the throughput. Now, throughput is the actual measure of what you are transmitting at a point in time. So a bandwidth can be of a particular media can be 1 gigabyte per second, but for some reason they are not able to transmit more than probably 700 or 800 megabytes per second. Probably it can be due to weather, it can be due to some other conditions that could impact the efficiency of the transmission. Now, so that is bandwidth and throughput. Then the next section talks about a local network, and that will discuss the network components. The first one, basic network component, is the clients and the servers. So clients and servers are basically host devices. Now, what differentiates them is the role that they play on network. And as we already know, or as we can infer, a server is what serves, while a client is what receives. So computers or hosts can actually play multiple roles. Like a server can play a role of multiple servers. You can have a server that is a web server that serves web pages. It can be an email server. It can be an FTP server and a host of other services that you can have configured. Then we also have intermediate devices. So a server in a typical network infrastructure contains the end devices, the intermediate devices. So end devices are the devices that are used by the end user, like your mobile phone, your personal computers, your printers, your scanners, your VoIP phones, and other devices like that. While intermediary devices are devices that connect from one network to another using what we call the network media. Now, how do you build a simple network? So, like I mentioned earlier, a peer-to-peer is a network in which the client and the server can just be a client and the server are for other hosts. So, at any point in time, either of these PCs can serve as a server and can serve as a host at any point in time. Then the next thing is the ping utility. This is an utility that is used to do like an end-to-end test of connectivity between a source IP and a destination IP. Then another utility is the trace route utility that is used to determine the number of hops that a packet travels from source to destination. And that would be the end of this section. We'll continue in the next module. So in this next section, we want to discuss about the things that you need to get online. What do you need to get connected to a network? Now, as we know, networks are everywhere. It has become ubiquitous. Everybody is now connected, either from your smartphone to your personal computers. We have ranges of networks from the 3G to 4G to now 5G networks now. We have other networks that are powered by smartphones like the NFC, Bluetooth, and a host of others. So, for you to get connected, there are some basic components that you need to get configured. Now, the first of them is the addressing, that is the IP address. So, every host on a network that will communicate on a network must have an IP address, kind of. As we go to advanced networking, we'll discuss more about this in more details. So now the IP address is actually a 4 octet number. Then we have what we call the subnet mask, which determines which network a host is connected to, and a default gateway. Now, IP addresses are configured either automatically or manually. So when it is configured automatically, that means you require a DHCP server to be on a network, like a device that serves as a DHCP server that assigns IP informations to other devices. Now, like we mentioned in the previous sections, for a typical network has the end devices, the intermediate devices, and the network media, which can be those that transmit information through pulses of light or electricity or wireless media. Now, like an high level overview, this we have what we call the topology. There are physical topology and logical topology. The next thing is cabling and media, like mentioned earlier. From those cables that transmits through pulses of electricity is the copper cable. Then we also have the fiber optic cables that makes use of pulses of light, then wireless devices. Now for the copper cable, they are usually twisted, and we have two types of twisted. It can be shielded and unshielded. The essence of shielding a twisted pair cable is to prevent it from electromagnetic interference and crosstalk, which are just some form of interference that disrupts the flow of communication on the network. When you have adjacent cables connected together, it can be subjected to interference. So the other type of cabling, the fiber optic cables that has a thin glass, then some shielding and carding to prevent it from to protect it. Then for the twisted pair cable, they basically come in two variations. There are usually 8 pieces of copper cables that can be differentiated with the varieties of colors. Now, when you have a single cable with two ends, you can either choose to arrange the cable using the TA or you arrange using the TB. Yeah, it does matter. What is of importance is that it's either you have both ends to be A or both ends to be B, or one end to be A and the other end to be B. So if both ends are the same, then you call it a straight through cable, while when both ends are different, it is referred to as a crossover cable. So each of these has their use cases. Although in recent times, most recent devices can actually find their way regardless of the arrangement of the cable. And so that will be pretty much the end of this section. So we'll continue from the next section in a bit. Thank you.